I'm gonna go get it.
It's easy fix. Easy fix. Just go munch on some grass, man.
Does it have a shape that makes confident anyway?
All right, so Carter, what you got?
Number 20 and 8-4.
Where are we at? Sorry.
8-4.
8-4.
The same that I'm probably just overthinking, but I'm not sure how to.
Yeah, that's not hard to do. Number 20.
Quasio.
All right, guys, this is section 8-4, number 20. What's up? Sorry. This is section 8-4. So the instructions say to sketch the curve and then find a rectangular coordinate equation, blah, blah, blah. Right, so the first step is to make your TXY table and plot it. And one little thing that's going to help you guys out a lot is, I don't know if you remember when we did piecewise? Remember piecewise? Does that sort of ring a bell?
Yeah.
And what we did was, if something was defined greater than 2, we still put 2 in.
Right.
We just said, oh, we just need to know where it would go, right? So on this problem, the picture looks kind of weird, and it's a little bit weird as to how to really get what it does at the endpoints. I'm not allowed to go to 0 or pi, and of course, why is that true?
That's where it is. That is less than
Yeah, that's where, which one has a problem?
cotangent.
Yeah, why would cotangent have a problem? Because sine is on the bottom, and sine at 0 and pi is 0. Kick ass, right? And of course, sine is on the bottom here too, right? So how are we doing so far? That's why I'm not allowed to use those, but I still have to kind of know what it's approaching there to put like an open circle, or maybe it's an asymptote or something. It makes sense because there would be asymptotes for both of these at that point. How are we doing so far? That's why we have to investigate this point. So the middle point shouldn't be that big of a deal. So, I mean, 0 and pi, and the one homework I graded from this assignment, somebody didn't do that. They got the middle points, but then they had to guess what it did on the outside, and they guessed wrong, which is really, again, easy to do, because this thing does something kind of weird. So I could put in there pi over 6 and pi over 4 and blah, blah, blah. That middle part should be easy. So if I try to plug in a 0, what's going on here? So what happens? What does cotangent look like? Yeah, good. So in the asymptotes, of course, are going to be, like we said earlier, at 0 and pi. And this guy, the tangent looks like that, so cotangent looks like that. So as you're trying to let x go to 0, what's the y piece doing? If you try to let t go to 0, the output's going to infinity, right? So the x just goes to infinity. And what does the y do? What's the y piece do? So again, what does cosecant look like there? So what is cosecant sits on top of the sine, right? So here's the sine, blah, 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 blah. Oops. What is it? Yeah, that's true. And then cosecant would be like this. So again, it's got asymptotes here and here. Right? So again, as you try to let t go to 0, that's going to go to infinity, right? I mean, I don't know if this is part of what you had trouble with, Carter. I was assuming this might be what you had trouble with.
Well, it's fine.
Everything.
I wasn't sure.
So the middle points, are they okay?
Yeah, well, I just wasn't sure what to do with it when it was,
Oh, on the next step, to get rid of t? Alright, so when you go to graph it, this is what I would suggest you do. Kind of figure out what it's doing at the endpoints. I think another problem is like this too. How do I eliminate t? How the hell would I do that? So, I mean, the most immediate way to do it, if you can't see any other way, the most direct way to do it is just to Solve for t. Yeah. Get t by itself. So if you can't think of anything else, now there is, I think you mentioned an identity, right? Of course, what identity relates to these two things? Yes, one of those. There's three of those.
Cotangent squared plus 1.
Yeah, so it's cotangent squared plus 1 equals cosecant squared. Cool. So what's cotangent squared?
X squared.
Cotangent's x. Cotangent squared is x squared. All right, cool. That's x squared. And what's cosecant squared? Y squared. Yeah. Believe it or not, it's that simple. It just doesn't feel like you should be able to do that, but you can. You totally can. And if you didn't see that, you could still do it if you solve for t. How do you solve for t? For like, let's do the x one. How do you solve for t? And of course, it sets up a little triangle. Right? Whenever I see an inverse trig function, especially because what I'm going to have to do with this immediately, I'm going to have to plug it in here to figure out what y is, right? So I got a little triangle I set up. Let's see if we get the same answer here. Let me just slow down here for a second. If you see the identity, awesome way to go, easy way to go. If you don't see it, you can always kind of fall back to this. When you have trig functions and you solve for t, you're going to get these inverse trig, and the minute you guys see this inverse trig, you should think maybe a triangle would help me. Especially because I know I have to plug it in, I got to figure out what the cosecant of this damn thing is. So if I could just set up a representative triangle, I can get the right ratio of sides for that, right? So what would the triangle look like related to this inverse cotangent? X is over 1.
X 1 minus.
So thankfully the x is actually going to be the
Right.
x side. Cool.
1.
And the hypotenuse is?
1 minus x squared.
No.
1 plus x.
1 plus x squared.
Oh, okay. Sorry.
Cool. That's okay. I figured. So now watch how this comes together. It still works. It works really decently well. And then also the nice thing for me is if you don't realize that, it's good because you get practice for this. Because if you're going into calculus, especially Calc 2 actually. Calc this happens sometimes. Calc 2 that happens a lot. What does it say then for y? Y is cosecant t. You don't need too many t's there, Jeff. So what's y equal to? What's cosecant, right? Yeah.
1 plus x squared.
Good?
Over 1.
Beautiful. Square both sides, you get the same damn thing, right? So either way you do it, you get to the same place. And to be honest, again, this happened once before. We know this has got to be plus or minus because now we're dealing with purely algebraic stuff. How did I get here? I took a square root. Because if I solve this for y, I'm going to get plus or minus rad 1 plus x squared. So when we do Pythagorean theorem here, I know it's going to be that. But it doesn't matter, just square both sides and it gets right back to the same thing. Maybe. So there are two ways to do that kind of problem. Identities kick ass. They're normally the quicker way to do it. Or this wasn't that bad. This really wasn't that bad, especially if you're more comfortable with this. If you're not comfortable with this is a bad way to do it. Is that cool?
Yeah, so you just then graph that.
Well, part A was graph it based off of this, and part B was just find this. Done. But then, I mean, hopefully once you get there, you can relate it to the picture you get and see how it makes sense. If it does. Yeah.
So then what's the purpose of the TXY?
Because that's for part A. Part A said graph it. And you're not allowed to use 0 and pi, so you definitely got to put the middle stuff in. But you still want to have an idea of what it's trying to do at 0 and pi. So you know kind of like either where to put an open circle or where it's headed. What's up?
I was just confused about...
So at 0...
About the whole portion of...
At 0, what's the x piece doing? Cotangent is going to be going to infinity.
Right.
So x is going to be going... So when I plot this, t of 0 gives me infinity. So I'm going to be coming from...
So
I'm going
on
to be...
the x portion you're using the cotangent graph, and on the y portion you're using the...
Because that's what they're defined to be. Yeah. So try this out. At least get this. Obviously, you're going to do the middle stuff because you know you can't use 0 and pi. But if you need some help on the ends, you think about, well, what would it try to do at 0 and pi? What would it want to do?
Okay.
All right, cool. That's my suggestion. Anything else from homework? All right, so let's do this. I want to start with you guys trying out real quick, just to make sure everybody understands how this works. Solving a system of equations using a matrix.
I don't think she's coming in.
So we got this here. What they want?
Yes, thank you.
Yeah, that's more than you wanted. All right, so you guys try this. Solve this using a matrix.